Okay, so we're going to be talking about the first topic in Unit 6. We skipped Unit 5 because that's what the math department decided we should do. So we're talking about transformations again, but this time on the coordinate plane. All of Unit 6 is talking about the coordinate plane, which deals with the x and y axis. A translation described on the coordinate plane is written by a rule that looks like this. A point is taken to another point by either adding or subtracting a number to the x and adding or subtracting a number to the y. So this rule right here is a translation. H units horizontally, which means right and left, and K units vertically, which means up and down, where adding results in shifting up or right, and subtracting results in shifting down or left. Okay, what that might look like, here's an example given. This point, xy, is translated by this rule. What this would look like is the point would be moved 2 to the right and 1 down. Remember, x dictates how far to the right or left a point is, and y dictates how far up or down a point is. This plus 2 would move it to the right because addition moves either up or right, and this minus 1 here would move the point down 1. The next transformation is dilation. Remember, dilation changes the size of a figure. It doesn't change the shape, but it changes the size. And what a dilation looks like is this point is transformed by taking the x and multiplying it by a number, should have been x, and taking the y and multiplying it by a number. Notice that the x and y are both being multiplied by k, and k stands for the scale factor. And all of our dilations that we're doing on the xy coordinate now are centered at 0, 0 at the origin. One thing you have to remember, for this to be a true dilation, the x and the y have to be multiplied by the same number. By the exact same number. The next transformation is a reflection, and the one that I'm going to show you is a reflection across the y-axis. Okay, reflection across the y-axis means this point is transformed by changing the sign of the x and leaving y the same. So let's look at what that might look like. If we have, let's say we're going to reflect this point across the y-axis, so it'll move this direction and it'll be over here. Notice the height or the distance from the x-axis didn't change, so it would have, both of these points would have the same y value. So point A over here, the ordered pair might be 2, 3, but when it's reflected across the y-axis, A prime is going to be negative 2, 3. Notice the sign of the x value changed, but the y value remained the same. If you were going to reflect A across the x-axis, if we were going to go across the x-axis, The x value would stay the same, but the y value would change sign. So it depends, and you might have to actually draw it out or sketch it out to remember exactly which one changes. But a reflection across the y-axis, the x changes sign. What I want you to remember or note is that this negative x means the opposite of x. Means change the sign. It doesn't mean x is negative, it means the opposite of whatever x was. Some things about transformations that we need to remember from what we've learned before is that translations and reflections are rigid transformations. They create congruent figures. Same shape and same size. A dilation, however, is not rigid and produces similar figures. Same shape, but different size. And that'll be important in just a little bit. Okay, so you guys don't have these examples on the blank template, but on the note key, you do. So there is one example that you won't have, that you'll need to write down somewhere. By the way, the password is Kinsey. Okay, so I'm going to do example number 1. Example number 1 looks like this. It's got an XY plane on the left. It says, for each point, and I'm kind of going to paraphrase because you have it. For each XY, find its image under the transformation x plus 5, comma, y minus 2, meaning the x is going to be increased by 5 and the y is going to be decreased by 2. So our 3 points are A, which is negative 6, 3, B, which is negative 2, 1, and C, which is negative 1, 4. So under the translation A prime, the x is going to be increased by 5. So negative 6 plus 5 is negative 1, and the y is going to be decreased by 2. 3 minus 2 is 1. B prime takes B's x, increases it by 5. Negative 2 plus 5 is 3. 1 minus 2 is negative 1. And then for C prime, negative 1 plus 5 is 4. 4 minus 2 is 2. So part B says sketch both triangles. Triangle ABC and triangle A prime, B prime, C prime. So triangle ABC, negative 6, 3, there's A. B is negative 2, 1. And C is negative 1, 4. Since this is a translation, and I know it's a translation because the x and the y are being added or subtracted by a number, then triangle A prime, B prime, C prime has to be congruent to triangle ABC because it's a rigid transformation. A translation is a rigid transformation. So let's plot triangle A prime, B prime, C prime. A prime is negative 1, 1. B prime is 3, negative 1. C prime is 4, 2. Okay, and you can see that they are the same shape and the same size. If they weren't, you would know that you either plotted some points incorrectly or that you calculated the transformation incorrectly, because a rigid transformation must produce congruent figures. Example number 2. This time we have a table. On the left is the original set of points, and on the right is the points after the transformation 2x, 2y. Part A says for each xy, find 2x, 2y. Now this is a dilation because the x and the y are being multiplied by the exact same number, 2. So the xy, that's -1, -3, -1, 1, 3, 1, and 3, -3. So all I do is I take the x's multiply by 2, take the y's multiply by 2. So this first point, -1 times 2 is -2, -3 times 2 is -6. -1 times 2 is -2, 1 times 2 is 2. 3 times 2 is 6, 1 times 2 is 2. 3 times 2 is 6, -3 times 2 is -6. So that's part A. We found 2x, 2y. B says sketch both, sketch xy and 2x, 2y. So what we should end up with are two similar figures. They should be the exact same shape, but different sizes. And as a matter of fact, the second shape should be twice as big as the first shape. And we'll see if we get that. Okay, so I'm going to plot the points in that left-hand column. -1, -3, -1, 1, 3, 1, 3, -3. I have this nice, neat little triangle with, square with sides length 4. So now I'm going to plot the points in this right-hand column, 2x, 2y. So -2, -6, -2, 2, 6, 2, and 6, -6. And you can see that I have a square now, same shape, that is twice as big. The side lengths are 8 now instead of 4. A student in the class asked, but shouldn't it be centered at 0, 0? The center of dilation is 0, 0. If you remember when we dilated without the coordinate plane, we made lines that went from the center of dilation through each point. So we would have done this through each vertex. And then we measured from the center to the first vertex, and then we would double it. So this actually is centered, the center of dilation is the origin. The center of the figures are not at the origin. Okay, example number 3 says transform triangle ABC using this rule. XY is transformed into -x, y. So since the transformation, the only thing that occurs is that the x changes sign, this is a reflection across the y-axis. So I'm going to plot the first triangle. I'm going to do it in black.